your vote doesn't count, or at least it doesn't count the same way that it would have 150 years ago. I'm talking about the Alabama paradox, which is basically a paradox that arose, I guess, in 1880, where they realized that if they increase the number of seats in Parliament, actually certain parties, the number of seats that that individual party got would actually go down, which is extremely counterintuitive. Let's look at an example. Imagine we had three parties, just A, B, and C, and the votes were 40, 60, and 100. So we can calculate the percentage of votes that each party got. So Party A got 20%, Party B 30%, and Party C 50%. Oops, just 50 I should put there. And let's say that the Parliament had 10 seats to give away. So there's 10 seats in total in Parliament. How many should each party get? Well, this is nice and straightforward. 20% for Party A, so they should get 2 seats. Party B has 30%, so they should just get 3 seats, and Party C 5 seats. Nice and straightforward. What if the Parliament had an upgrade, and instead of having just 10 seats to give away, they could give away 13 seats? So there were 13 seats. They managed to buy 3 more chairs in Parliament. What could they do here? How would they decide which party gets the vote? Well, let's just do the same thing. Let's work out 20% of 13. That's 2.6. 30% of 13, that's 3.9. And 50% of 13, that's 6.5. Okay, so these were the old numbers when we had 10 seats. Now we have 2.6, 3.9, and 6.5. And now, of course, the issue here is, well, you can't have a decimal number of seats. So how do we choose out of these numbers which to round up and which to round down? And there are various methods you could use here. But today I'm going to be using the largest remainder method, which is what was used in the US up until 1880. And that's when the Alabama paradox was kind of discovered, and they realized, hold on a second, this makes an issue. Okay, so what is the largest remainder method? Well, we've got 13 seats to give away, so we're definitely going to give at least 2 to Party A, at least 3 to Party B, and at least 6 to Party C. So just these kind of integer parts of each number. And then we're going to either add 0 to these numbers or add 1. And how are we going to do that? Well, we're going to do 2 plus 3 plus 6, so 2 plus 3 plus 6 is 11. So that we've so far occupied 11 of the 13 seats. So we have 2 to give away. So we're going to give those 2 away to those which have the largest remainder. So we've got 0.9, 0.5, and 0.6. So 0.9 and 0.6 are the biggest. So these 2 will get the extra seats. So Party A would have 3 seats, Party B 4 seats, and this would get 0 extra seats. So it would just stick with 6. And then you get all your 13 seats filled. And this seems like a fairly valid way to prescribe the number of seats that each party gets. However, here's where the Alabama paradox comes into play. In 1880, it turned out that there was a scenario where if you increase the number of seats, like we did here, that actually caused the numbers here to go down. So if you notice here, we went 2 to 3, 3 went to 4, 5 went to 6. All those numbers went up, or worst case scenarios, they stay the same. But there was actually a scenario where those numbers went down, and that obviously seems to kind of go against intuition. So let's have a look at that. Okay, so let's talk about the Alabama paradox. Here's an example where this taking the biggest remainder doesn't actually work. So if we have 3 parties, let's just say we have 6 votes, and 2 votes. 6 for A, 6 for B, and 2 for C. And I've calculated the percentages here. So it's approximately 42.857% for A and B, and then 14.286% for C. Okay, and let's imagine Parliament has just 10 seats. Okay, well, if we do this, then, well, what's 42.857% of 10? Well, that's 4.2857, blah, blah, blah. Same thing here. And then this guy would be 1.4286 seats. Okay, and we're going to do the same thing and work out, well, which ones do we round up, which do we round down? So we've got 10 seats here. So this is going to have at least 4, and at least 1. And that gives us 9 seats. So if we want to fill 10, we've got 1 left to fill. So we take the one with the biggest remainder. That's this guy here. So that gets 1 plus 1, which is 2 seats. Great. What if instead the Parliament had 11 seats? How would this go here? Well, again, I've worked out the percentages, or the calculation. So if you do 42.857% of 11, that turns out to be 4.7143 approximately. You'd get the same thing here. And then this is 1.5714. So those would be the kind of decimal seats you'd get, but of course we've got to make these integers. So we're going to do 4 plus 4 plus 1, and then that is so far 9 seats. And so we've got 2 left, so we're going to take the 2 with the biggest remainders. Well, that's these 2 guys here, because they're 7, 1. whereas this thing here is 5, 7. So we take this guy here, and so we add one to these, add one to this, add one to both of those, sorry, and so we get 5, 5, and this stays as 1. And here's the kind of issue is, how can the number of seats that Party C get have gone down despite the total number of seats available have gone up? And that's the issue. That is the Alabama paradox. So actually, I'm not going to discuss how we can resolve this issue. I'm actually going to leave that as a bit of homework for you guys, or maybe you have your own theory, so let me know in the comments down below. But if you have found this video interesting or useful, please do give it a like, share it with someone who you think might be interested in this. I've never made a video about voting in maths before, and there's lots of other interesting theories to do with it, so if you want to see some more on that, let me know as well. Thanks so much for watching. If you are able to vote in the upcoming elections in the UK, please do. Or if you're in the US, I think you got some in November. And if you've got elections anywhere near you, your say definitely does count.